Sometimes we might have a fraction with quadratic factors. In a case like this, the process of decomposing such fraction is a little bit different from that of a linear factor, as for fractions with quadratic factor, the constant will be 2. It won't be 1 in this case. So what am I saying makes sense? Let's try to use some examples to analyze that. Consider x plus 6 all divided by x plus 2, then multiply by x squared plus 4. Please, before you proceed on decomposing a complex fraction into smaller forms using the idea of quadratic factors, kindly make sure that you have confirmed it very well that the quadratic expression can't be factorized. Because if it can be factorized, it is highly recommended to factorize it and use the idea of partial decomposition using the linear factor approach. So we can see that we are having a linear factor and a quadratic factor. So what we do is that we assign a certain constant a with a linear factor x plus 2. Then plus, now for the quadratic factor, it has two constants. The first one is b, which has to be associated with x, and the other one is c, all divided by x cubed, okay, x squared plus 4. And that's it. Having done this, the next process is similar to that of linear. We just need to multiply each term by what we see right here. So let me reduce the terms, everything, so it can be easy for us to multiply. Perfect. So now I'm multiplying everything by x plus 2 and x squared plus 4. So now for the red color, the whole terms are cancelled out and left over is just x plus 6. And for the yellow color, x plus 2 cancels x plus 2 and left over is a multiplied by x squared plus 4. And for the green color, x squared plus 4 cancels out x plus 4 and left over is just x plus 2 multiplied by bx plus c. Now, one thing I like about problems involving quadratic factor is that the process of finding those constants is fixed. It's not that you get this one first before you get the other one, and later get the other one doing them randomly. Everything is fixed. There's a particular constant you need to get before you get the rest, and that is in the first place you have to determine the value of a. To determine the value of a, all this term over here has to be 0, and for it to be 0, just set whatever you have here to be 0 and solve for it. So x plus 2 is equal to 0. So x has to be negative 2. At x equals negative 2, this whole term will be 0. You can clearly show that, but I won't do that. So left over when it becomes 0 is just x plus 6 equals a multiplied by x squared plus 4. Now if I plug in negative 2, I have negative 2 plus 6 equals a in the bracket of negative 2 all squared plus 4. And simplifying this forward, we have plus 4 equals a in the bracket of 4 plus 4. Negative 2 squared is simply positive 4. And 4 equals a in the bracket of 8. Dividing through by 8. And final answer, a equals 1 by 2. So the value of a is equals to 1 over 2. Having gotten a, the next term you need to determine is the value of c. To get c, bx has to be 0. For bx to be 0, x must be equal to 0. In all cases, x will always be 0 in order to make bx to be 0. Now, if bx is 0, we will just be left over with x plus 6 equals a in the bracket of x squared plus 4. And this will be plusing c multiplied by x plus 2. Why? Bx has already been 0. C plus 0 is c. Now, plugging in 0 for x respectively, we should have this. And simplifying forward, we have 6 equals 4a plus 2c. A is 1 half, 4 times half, plus 2c. And 2 reduces 4 all the way to 2. Then we should have, I'm creating more space, 6 to be equals to 2 plus 2c. Subtracting 2 from both sides, 6 minus 2 equals 2c. And 4 equals to 2c. Dividing 2 by 2, c eventually results in 2. And c equals 2. Having gotten c and a respectively, it's easy for us to determine the value of b. To determine the value of b, you can substitute any suitable value for x in the equation. But make sure that you won't substitute something that will make b to be 0. That means x can never be 0, but can be any other thing. So let me plug in 1. At x equals 1, I have 1 plus 6 equals a in the bracket of 1 squared plus 4. Then plus b times x, that's b times 1, b plus c, then in the bracket of 1 plus 2. 1 plus 6 is 7 equals a is 1 half in the bracket of 1 plus 4. Then plus b is what I'm solving for, plus c is 2, then multiply by 3. 7 equals to 5 by 2 plus 3 times b, that's 3b, then plus 3 times 2, that's 6. Now, I would like to subtract 6 from both sides. Then I have 7 minus 6 equals to 5 by 2 plus 3b. And that results in 1 equals to 5 by 2 plus 3b. To keep things straightforward, what I would like to do is to multiply all through by 2. 2 by 1 equals 5 by 2 times 2 plus 3b times 2. And that results in 2 equals 5 plus 6b. So now what I would like to do is to bring 5 to the side, or let me say subtract 5 from both sides respectively. Then I have 2 minus 5 equals to 6b. 2 minus 5 results in negative 3, and that is still equals to 6b. And dividing 2 by 6 will eventually have b to be equals to negative 1 by 2. So a is 1 half, b is the negative of a. We have everything we need to write the decompositions. So eventually, x plus 6 will result in x plus 2 multiplied by x squared plus 4. And that will result in a divided by 1 by 2. I will just write it as 1 divided by 2 in the bracket of x plus 2. I believe you should understand how I brought the 2 all the way down. I use the concept of keep, change, and flip. It should be 1 by 2 divided by x plus 2. And using the concept, we have to keep the first fraction, change the sign to product, and flip that fraction, the other fraction, that's x plus 2. It's actually what x plus 2 over 1. If I flip that, that would be the reciprocal. And eventually, that should be 1 divided by 2 x plus 2. That's how I got this. Perfect. So let's continue. Now, what about b? So b is negative 1 half. So I'm just going to have plus negative 1 half x plus c is 2. Then that's divided by x squared plus 4. To keep things balanced, to keep things looking more funimorous, let me multiply both the top and bottom of this by 2. And that will be 1 over 2 in the bracket of x plus 2 plus negative x plus 2 Okay, plus 4 divided by 2 in the bracket of x squared plus 4. And finally, I would bring this to the side to keep things perfect, look more charming. X plus 2, then plus 4 minus x, all divided by 2 in the bracket of x squared plus 4. Please be very careful because I believe many students will want to make such kind of mistake. Don't turn this to negative because this is negative. If you do that, then this also has to be negative. Meanwhile, it is not negative but positive. So just let it be how it is. If you want to make things look more perfect, then you can do it this way. And that is the solution to the first problem. Number 2, consider 4 divided by x plus 2 multiplied by 2x squared plus x plus 6. Feel free to pause the video and check this question out yourself. If you haven't subscribed to my channel, please do well to subscribe to my channel. First, are we sure that this quadratic expression can't be factorized anymore? Judging what I'm saying, it is impossible for me to factorize this. In fact, it is a complex root equation. If we solve this, I'm very sure it will lead us to complex root because this is just 1. And 4ac, that's negative. Sure. Now, therefore, we'll be having a constant term a for the linear term x plus 2. And we have the quadratic term, the quadratic constants bx plus c for the quadratic term or quadratic expression or quadratic factor x squared plus x plus 6. Perfect. Now our main goal is to multiply both sides by the whole factor of the given equation. So here it is. So I'm having x plus 2, 2x squared plus x plus 6. For the red color, the whole term cancels out and left over is simply 4. The equal sign. For the yellow color, x plus 2 gets rid of x plus 2 and left over is 2x squared to be multiplying a outside then plus x plus 6 inside. For the green color, 2x squared plus 6 plus x cancels out 2x squared plus 6 plus x. And left over is just plus bx plus c to be multiplying x plus 2. Perfect. So now, our main goal is to solve for the value of a, b, and c respectively. So to determine the value of a, we need to make this whole term to be 0. And to do that, we need to set x plus 2 to be equal to 0 and determine the value of x at that point. You notice that x will simply be nothing but negative 2. So at x equals negative 2, this whole term is 0. And we will be left over with a multiplied by 2x squared plus x plus 6 equals to 4. Since x is negative 2, I'm just going to plug in that negative 2. And we have a in the bracket of 2, negative 2 all squared plus negative 2 plus 6. And simplifying this forward, we have a in the bracket of 2 multiplied by 4. Negative 2 squared is 4. Then plus times minus 2, that's minus 2 plus 6. And that's 4 equals to a in the bracket of 8 minus 2 plus 6. And that should be 12. 8 plus 4 is 14. Sorry, 8 plus 6 is 14. Then minus 2 is 12. Dividing through by 12, we can clearly have the value of a to be equals to 1 by 3. That's 1/3. How did I get 1/3? 4 can go in 12. How many places? 3 places. 4 can go in 1 places. And that is how a results in 1 by 3. Having gotten the value of a, we can now determine the value of c. To determine the value of c, we just need to set x to be equal to 0, as that will help us to make bx to be equal to 0. At x equals 0, we have 4 to be equals to a in the bracket of 2x squared plus x plus 6 plus this has become 0 because b times 0 is 0. And we're left over with c in the bracket of x plus 2. Plugging in that 0, we have a multiplied by 2 times 0 squared plus 0 plus 6 plus c in the bracket of 0 plus 2. Simplifying forward, we have a multiplied by 6a plus 2c. But a is 1 over 3, and we should have 6 times 1 by 3 plus 2c. Using this, we have 4 to be equals to 2 plus 2c. Then subtracting 2 from both sides, we should have 4 minus 2. Oops. 4 minus 2 to be equals to 2c. And 2 equals 2c, dividing 2 by 2, c equals 1. So the value of c is indeed equals to 1. Now that we have c and a respectively, it's easy for us to determine the value of b by just substituting a suitable value for x. Just make sure that you don't substitute what will make b to be 0. That means x can be anything, but not 0. So let's plug in 1. At x equals 1, we have 4 equals a in the bracket of 2 in the bracket of 1 squared plus 1 plus 6 plus b multiplied by 1, that's b, plus c in the bracket of 1 plus 2, that's 3. So plugging in the value of a and c respectively, 1 by 3 in the bracket of 2 plus 1 plus 6 plus the value of b which we are looking for plus 1, then multiplied by 3. Simplifying this forward, we have 1 by 3 times 9 plus 3 times b is 3b, 3 times 1 is 3. This reduces this, so 3 plus 3b plus 3. Adding this up, we have 6, then 4 equals to 6 plus 3b. So we can subtract 6 from both sides in order to determine the value of b. So therefore 4 minus 6 equals to 3b, and eventually 2 equals 3b minus 2. So dividing 2 by b, 3 rather, then we have b to eventually result in negative 2 by 3. Now we have everything we need to get the decomposition. So let's write the decompositions. So therefore, finally, 4 divided by x plus 2 multiplied by 2x squared plus x plus 6 can be decomposed to a, which is 1 by 3. So I will bring the 3 all the way down. X plus 2. By now you should know what that means in essence. Plus the value of b is negative 2/3. Multiplied by x plus the value of c, that's 1, all divided by 2x squared plus x plus 6. So to keep this balance, we don't want to have fraction on the top. We can multiply all through by 3 over 3. So that will result in 1 divided by 3 in the bracket of x plus 2. Then plus this cancels this and it affects this to be 3. Perfect. And now we have negative 2 plus 3, 2x to c, divided by 3 in the bracket of 2x squared plus x plus 6. This minus won't turn this to minus, be careful. So finally, final answer should be this. 1 by 3 over x plus 2, then plus 3 minus 2x, all divided by 3 in the bracket of 2x squared plus x plus 6. And that is the final answer to the problem. Hopefully you got that. Let's consider one more example for easy understanding. By the way, I want you to try this out yourself. Pause the video and check this question out yourself. The first question, has this problem been completely factorized? It is not that it is not yet. This are difference of two squares, as it can be written as this: 16x all divided by x squared all raised to the power of 2 minus 4 squared. Or let me say, yes, 4 all raised to the power of 2. And the properties of difference of two squares, a squared minus b squared, is that they can be re-expressed as a minus b, a plus b. If that's the case, this can become 16x all divided by x squared minus 4, then x squared plus 4. Perfect. But we are trying to solve a problem, but the problem still persists. We still have difference of two squares, so we still need to solve that one too. I hope it doesn't persist anymore. Let's see. 16x all divided by, since it is x squared minus 4, it can be expressed as x squared minus 2 squared. So that's going to be x minus 2, x plus 2. So therefore we have x minus 2, x plus 2 multiplied by x squared plus 4. Be very careful. X squared plus 4 can be factorized or simplified to any lowest term anymore, as that is the end. Now we have everything to be simplified to the lowest term. We have factorized this given complex fraction completely. The next thing is to decompose it. So let me bring it upward a little bit so we can have enough space. Now what we are going to do is to plug in the first constant for the first term, that is linear, x plus 2. But the second term turns out to also be linear. Okay, the first term is x minus 2, plus b divided by x plus 2, then plus cx plus d divided by x squared plus 4. So this is how to write all these constant terms for this complex fraction. I hope you got that. It is only for the term with the quadratic factor that we have two different constants. Which one will be associated with x and the other one will be standing alone. Be very careful and sensitive. So now, just as we have been doing, we are multiplying everything all through by x squared, sorry, x minus 2, x plus 2, x squared plus 4. I don't have enough space, so I will need to reduce the font a little bit. So it should work perfect now. I think that space should be enough. So I'm multiplying that with x minus 2, x plus 2, then x squared plus 4. So now for the red color, everything cancels out. And left over is 16x. Then we have the equal sign. For the yellow color, we are left over with x plus 2 and x squared plus 4. So that's going to be a multiplied by x plus 2, x squared plus 4. For the green color, x plus 2 cancels out. Left over is x minus 2, x squared plus 4, plus b multiplied by x minus 2, x squared plus 4. And for the blue color, x squared plus 4 cancels out x squared plus 4. Left over is plus cx plus d multiplied by x plus 2. Then let me try to bring it a little bit more forward, or backward rather. Then multiply by x minus 2. So this is the simplified form of it. So as we have been doing so far, our main goal is to determine the value of a first. X has to be here. That was actually a, just keep my mind, x has to be there because actually 16x. It's actually 16x. So now let's determine the value of each of those constants respectively. So we have to find the value of A first in all cases. How can we determine the value of A? To determine A, we need to make this 0 and also this 0. And to do that, we need to look for a term that is present in all cases. It's present here and it's present there too. That's x minus 2. So at x minus 2 equals 0, this whole term be 0 and this also becomes 0. So definitely it will be at x equals 2. At x equals to 16x equals to A in the bracket of x plus 2, then multiply by x squared plus 4. Plugging in that 2, we have A in the bracket of 2 plus 2, 2 squared plus 4. And that's 32 equals to A in the bracket of 4 multiplied by 8. And that will be indeed equals to 32 equals to 32A. Dividing 2 by 32, then the value of A equals 1. So A is equal to 1. Having gotten A, we have to proceed to the next constant. And that will be B in this case. Look for a term that is present here and here in order to make it 0. That should be x plus 2. At x plus 2 equals 0, x is equal to minus 2. And in this case, we have 16 equals, this has been 0, this has also been 0. B in the bracket of x minus 2, x squared plus 4. So if I plug in negative 2, 16x to say, equals B in the bracket of negative 2, then multiply by negative 2 all squared plus 4. And that's 16 times negative 2 equals to B in the bracket of negative 4 multiplied by 4 plus 4. Negative 2 squared is indeed equals to 4. 16 times negative 2 is negative 32. And negative 4 times positive 8, that's negative 32b. Dividing 2 by negative 32, b is indeed equals to 1 as well. So unlike a, b is also 1. Having gotten b, we can determine the value of d. To determine the value of d, we just need to make cx to be 0. For cx to be 0, x has to be 0. At x equals 0, 16 times 0 equals to a in the bracket of 0 plus 2. I've been plugging in everything directly. 0 squared plus 4, just to keep things easy. Then b plus b in the bracket of 0 minus 2. Then we have 0 squared plus 4. And we have plus cx has been 0. Left over is just d in the bracket of 0 plus 2. Then 0 minus 2. That seems too much long. 16 times 0 is 0. We have a multiplied by 0 plus 2, that's 2. 0 squared plus 4, that's 4. Plus b in the bracket of negative 2. Then multiply by 4 plus d in the bracket of 2. Then multiply by negative 2. Simplifying that, we have 2 times 4, that's 8a. Plus negative 2 times 4, that's negative 8b. Then minus 4d. That's equal to 0, don't forget. So now, what are we doing next? Is 0 will still be equals to the value of a is 1, 8 times 1, minus 8b, 8 times 1 again, minus 4d. So that's 8 minus 8 minus 4d. This cancels out. The value of d will likely to be 0. I think it's 0. So 0 equals to minus 4d. Divided into by minus 4. D equals 0. So d is 0. Having gotten d, we can get the value of c. To get the value of c, all we need to do is to plug in a suitable value for x. There's no certain value. You can use any value. Just make sure that you use something that doesn't make cx to be 0. So you can't use x equals 0. So I'll use 1. 16 times 1 equals to a in the bracket of 1 plus 2 in the bracket of 1 squared, which is 1 plus 4, plus b in the bracket of 1 minus 2, then multiply by 1 squared plus 4, which is 1 plus 4, plus cx, which I'm looking for. Well, c times 1 is just c. Let me just write c plus v, which is 0, in the bracket of 1 plus 2. Then multiply by 1 minus 2. 16 times 1 is 16 equals to 1 plus 2 is 3. 1 plus 4 is 5. 5 times 3. That's 15. 15a plus 1 minus 2 is minus 1. 1 plus 4 is 5. Multiplying them is minus 5. B. So this cancels out. Plus c plus d, that's c plus 0, that's c, multiplied by 3 in the bracket of minus 1. 16 equals to 15a minus 5b minus 3c. So now let's plug in the value of a, b, and c respectively. So 16 equals to 15. A is 1. 15 times 1 is 1. Minus b is 1. 5 times 1 is 5. Minus 3c. 16 equals to 10 minus 3c. I wrote 36. So 16 minus 10 equals to negative 3c. And 6 equals negative 3c. Divided into by 3. C equals to negative 2. And that is the answer. Whoops! We finally end up with everything. Now we can write the decomposition. 16x all divided by x minus 2, x plus 2, x squared plus 4 will now be equals to 1 by x minus 2 plus 1 divided by x plus 2, then plus that will be cx, that's negative 2x, d is 0, I'm now writing d again, divided by x squared plus 4. This is our final answer. And that's it for this problem. Hopefully you find this content helpful. If you haven't subscribed to my channel, please do subscribe to my channel. Thanks for watching. See you guys in the next video. Bye for now. Subscribe.